So in the previous video, we have defined what a payoff function is. A payoff function is a mapping from the action set, that is the set of all possible actions by a player, to the set of real numbers. So this mapping assigns a numerical value to every possible actions of a player. Here the A1 belongs to action set A, and this number represents the happiness of that player. So the higher the amount of the payoff, the more happy the player is. So this number can be the monetary value, but it does not always have to be. It can be some random numbers. For example, as in the previous video, we have seen that the happiness for coffee can be 1 and the happiness for tea can be -1. But one important thing to note that this mapping is not constant, and it depends on what the other players in a game are doing. Right? For example, let's consider the game of Coke Pepsi from last lecture. So let's see what the payoff function of Coke can be. So Coke has two options, two actions: to advertise or to not advertise. So we want to know what the payoff for advertisement would be and what the payoff of not advertisement would be. If you remember from the previous video, that this payoff depends on whether Pepsi decides to advertise or not. So if Pepsi decides to advertise, and then this means that Pepsi decides to advertise and Coke also decides to advertise. So the payoff for Coke would be, in this case, so if they both decide to advertise, the payoff was $3 million for Coke. And if Pepsi decides to advertise and Coke decides not to advertise, the payoff was $1 million. Right? So this is the payoff function of Coke if Pepsi decides to advertise. However, if Pepsi decides to not advertise, then the payoff function would change and it would look like this: not advertise. So if Pepsi decides not to advertise and Coke decides to advertise, so the payoff would be $9 million for Coke. And if Pepsi decides not to advertise and Coke also decides not to advertise, the payoff would be $5 million. So you see how the decision of another player changes the payoff function or the mapping. So in this case, we can write it in a tabular form. So in the row, here we will write the all possible actions, say the payoff for advertisement, the payoff for not advertisement. So if Pepsi decides, so we will split into two columns. So if Pepsi decides to advertise, then the payoff function would look like $3 million and $1 million. And if Pepsi decides not to advertise, then the payoff function would look like $9 million and $5 million. So if there are some other variables, for example, this payoff function can vary from one region to another region. Say in India, the payoff function might look like this, and in Bangladesh, the payoff function might look like might look completely different, right? So while we are discussing payoff, another important definition is optimal action. and we denote this optimal action using this notation A star. And of course, A star would belong to a set of all actions. So, an optimal action is defined as an action which maximizes the payoff. So for all possible actions, we will look into the corresponding payoffs, and the action that gives the maximum payoff is called an optimal action. So mathematically we can write an optimal action which belongs to the action set is an action such that the payoff of that action is greater than or equals to payoff of any action A for all A belongs to A. Note that this symbol, the upside down A, this means for all. So this is the mathematical definition of an optimal action. So again, this means that the payoff of A star or the optimal action is greater than or equals to payoff of A for all actions that belongs to the action set. So for example, in case of Coke Pepsi, we saw that the optimal action for both Coke and Pepsi was to advertise. And in case of, this was for Coke or Pepsi. And if you remember from the Big Monkey Little Monkey game, in that case for Big Monkey, the optimal action was to wait. And in the first case, the set of all actions was to advertise or to not advertise. And in this case, the set of all possible was, and in this case it was wait or to climb. So why this is the optimal action? Because the payoff of advertisement is greater than or equals to the payoff of not advertisement. So if you see from this example, so in both cases, whether Pepsi decides to advertise or not advertise, the payoff of advertisement is greater than the payoff of not advertisement. So for Coke and Pepsi, so for Coke, the optimal action is to advertise. So that's why A star is equal to advertisement. Now let's look into another example. Say you are given two job offers, J1 and J2, and let's assume that J1 offers 15,000 BDT per month and J2 offers say 20,000 taka per month as a salary. So your action set in this case would consist of two actions, either to accept the offer of J1 or to accept the offer of J2. And what are your payoffs in this case? Well, the payoff for job 1 is 15,000. And payoff for job 2 is 20,000. Note that we are assuming that the monthly salary is the payoff in this case, but this might not always be the case. For example, although this might be the case that although J2 is offering higher salary, it does not have a very professional work environment. Although J1 is offering a lower salary, it might have a more favorable environment for you. So this can vary from person to person. So for simplicity, let's assume that the both companies, they offer the same environment and all the other variables, and the only factor that's different is the amount of salary. So this is your payoff function. So this is the set of all actions, and this is your payoff function. So in this case, what would be the optimal action? It would be J2. So the optimal action in this case is to accept the offer of J2, because your payoff, which is defined as the monthly salary, is maximized in case of J2.